absorbance will be 0 time, that's mean A0. So if we integrate them, then what will be the products? As we all know, integrate of 1 into dx equals to x. So 1 into dA, it will be a, and the limit will be at a0. We'll learn in this video order of reaction. Order of reaction is defined the number of concentration terms on which the rate of a reaction depends when determined experimentally. From this, we will learn today zero order reaction. Zero order means the rate does not depend on the concentration terms of the reactants. If the rate is R means minus dc by dt, equals to will be k naught, equals to k naught. Here k naught is the specific rate constant. It is the rate constant. So the rate equation will be R equals to k naught or minus dc dt equals to k naught. An example of zero order reaction is oxidation of vitamin A. Oxidation of vitamin A in oily solution. Oxidation of vitamin A in oily solution. This is the example of zero order reaction. Here C is the concentration, initial concentration of the reactant. In zero order reaction, the rate must depend on some factor other than the concentration term, like the rate limiting factors, solubility, as in suspensions. So in suspension, we will calculate zero order reaction through solubility. In certain photochemical reactions, we will take absorption of light from the unreacted product, from the unreacted reactant, absorption of light. So, as zero order reaction does not depend on any concentration, so we will take either solubility for suspension or for absorbance for photochemical reactions. We will take absorbance for the derivation. So, our equation will be rate equation will be minus dA divided by dt equals to k naught. Here dA, A is the absorbance, T is the required time, and k naught is the rate constant for zero order. If we take dt on the other side, then it will be dA equals to k naught into dt, and we will take the minus 1 to the right side. If we integrate both sides, then it will be, as minus k naught is a constant, so it will be integration of dt. Our limit will be time, highest time is t and lowest time is 0. Highest absorbance will be at t time, so it is at, and minimum absorbance will be 0 time, that's mean a0. So if we integrate them, then what will be the products? As we all know, integrate of 1 into dx equals to x. So 1 into dA, it will be a, and the limit will be at a0 equals to minus k naught, it will be t, and the limit will be t comma 0, t to 0. So it will be a t minus a0. We will put the maximum value first, then minus minimum value. Here minus k and it k naught, that's mean it's the rate constant of zero order. It will be t minus 0. So our equation will be at minus a naught equals to minus k naught t. If we take the k naught to left side, then our equation will be k naught equals to minus for minus 1 multiplication, it will be a naught minus at divided by t. This is the equation for rate constant for zero order reaction. If we take the initial concentration, means amount of substance unreacted at initial is C, is A, and AT is C, that's mean at T time the absorbance is C, concentration is C, then our equation will be A minus C divided by T. It's another representation. So here we can find out the value C will be A minus K naught T. If we take the graph from this, what will be then? In the graph, we will represent at y-axis the absorbance means A minus C, and in x-axis we will be plot times. So it will be x-axis and that will be y-axis. So if we take the graph, then we will see that it will be a straight line like this. Why it will be a straight line? But if we find the slope from this, we will see that slope will be k naught. Why slope will be k naught? If absorbance is A minus C, that's when it will be y, and these will be x. So A minus C equals to k naught into t. Here absorbance in y-axis, so it will be regarded as y, and k naught are constant, so it will be m, and t is on x-axis, so it will be x. Y equals to mx. It's an equation for a straight line. Here m is the slope of the equation, slope of the straight line. So in m we will find k naught, so that from the slope we will find k naught easily. So we will plot A minus C on the y-axis and time in the x-axis. Then from the slope we will get k naught. But remember, is the slope negative or is the slope positive? From here, we can say that from slope, we can find the formula is y by x, or y2 minus y1 divided by x2 minus x1. If we point these and these coordinates, from this we can see that if it is y2, x2, and it is x1, y1, so y2 is greater than y2 is less than y1, so y2 minus y1 is a negative value, x2 minus x1, that's mean this point. So here x2 is greater than x1, so it will be positive, minus divided by plus, so the overall value will be negative. Here the slope will be negative, but if the absorbance over time increases, then so now we will be see the absorbance is increasing over time. In y-axis it will be absorbance, and in x-axis it will be time. So the graph will be over time absorbance increases. That's mean at the initial time it will be least amount. Over time it will be increases in a straight line. So again we will find from the slope k naught. But here the k naught will be if it's it will be x1 because this point this point comes first, and this point will be x2, y2. So y2 is greater than y1, x2 is greater than x1. All value will be positive. So y2 minus y1 divided by x2 minus x1 will be positive. Our slope will be positive. So we learned that absorbance versus time graphs for zero order is a straight line. It can be positive slope, it can be negative slope for a reason. But here we will learn about T half or half-life. Half-life means is the time required for the concentration of the reactant to reduce to half of its initial concentration. That's mean our rate reaction is rate constant. If rate constant is k naught, it will be a minus c divided by t. A is the initial concentration, initial absorption, initial concentration, and it will be the final concentration. So we will take time as a half. That's mean it will be t half. Required time for the concentration of the reactant to reduce to half. That's mean C will be A by 2. Got it? So here T will be T half. So K naught will be A minus C. For C we will write A by 2. In T we will write T half. I will derive the value of T half. So T half will be A. From A minus A by 2, if we subtract, it will be A by 2. That's when it will be K naught. So our equation will be T half equals to A by 2 K naught. It will be the equation of T half. So T half A divided by 2 K naught. If we know the value of initial concentration and rate constant for a zero order reaction, we will get easily the value of T half. So we will learn this equation for the derivation. But one thing to remember is a zero order reaction has successive half-lives which decrease with time. That's mean if we have a zero order reaction, then successive half-life, it will be first half-life T half, it will be the second half-life T second half. So first of all, the duration for first half-life is this amount, and the duration for second half-life is this amount. So we can say that successive half-lives which decrease with time. First T half is greater than second T half. It's a characteristic for a zero order reaction. Thank you.